But what? No.
Right, 4 lessons.
Yeah, but these are big lessons. These are big lessons.
So it takes 2 hours for that?
Well, I don't know. Maybe not the first one, but certainly the last one. What's the delay? What happened? Possibly. Where were you coming from? Where are you coming from?
You were so hungry. I'm sorry.
And where have you been lately? You've been a bit absent lately, haven't you?
No, it was just yesterday.
That's what I meant.
Did you miss my silence?
With Mr. Wisecracking jokes, yes. Let's see now. Might go out. I haven't decided yet. No, sorry. You've used up one.
No, you guaranteed satisfaction.
I don't think I said that, did I?
Yes, you did. Yes, you did.
Sorry, satisfaction for me. You've got it backwards, my friend. It's the other way around.
As you're saying, guaranteed satisfaction.
Where is my further integration?
It's my fault.
Yeah, yeah. Well,
that's why they've only just arrived.
Yeah. That's the impression I got from them. So I shouldn't punish them, right? So I shouldn't punish them. A little, okay. Yes, yeah. What delayed him?
I wonder.
We were doing pedigree.
Isn't that dog food?
No. You know what pedigrees are. Come on. You're a
Sorry, being a wise guy. Being a wise guy. Yeah. Yeah, I think so. Or no, most likely we'll start our coursework too.
When are we going to start?
As soon as we finish this book, I think that'd be good.
And after that, is there a systemic way of like doing questions or?
We'll just work from past exams. No big deal.
Just like on this semester.
Is the coursework we do after the final exams?
Of course not.
Have you corrected coursework, or have you been given those?
Have not, which is annoying. Which is quite annoying, to be honest.
Isn't it like April soon?
Yeah, look, listen, I don't control the people above me.
What if they never give it?
That is interesting, and that is also possible.
What if they don't give it until May?
That's it, this is possible.
Wasn't the same case last year?
No. Okay, I think have we got everybody now?
Imagine they did give the openings in your senior spam. And you just did not.
I think your question is down to
I used one. And I said, not.
Right, is there anyone else going to come in, or is this everyone? Let's check. Can I borrow a pen there, Mo? Just, thank you. Let's just see if I got everyone now. Mahmoud?
Yes.
Gafar? Amjad? Zara? Zara? No? Mo? Daniel? Daniel? What? Okay. Savi? Sabrina? Elfrida? Arya? Chidi? Young Peng? Amna? Amna? Mariam? Michelle? Michelle? Yeah. Abir? Autumn? Celine? Sophia? Mubarak? Shadara? Shadara? No? Well, she's not here now, so we're marking her absent. Mohammed? Sabrina? No. Moza? Angela?
You're
10 seconds late.
What the hell?
I'm marking you absent for the first class. Where was I? Moza? Yeah. Angela? Ahmed? Safra? Safra? Neil? Okay.
Isn't the attendance policy 15 minutes?
No, I told you a week ago I was changing it because people wanted a bit more snappy of a start. So I said, if you're not here when I call your name, I'm marking you absent. That's what I said.
Yeah, but
And then I said, if you're 15 minutes late, then I'm not letting you in. Unless you have some good reason, like you're at immigration or you emailed me saying you were sick or whatever.
or the teacher from the last class that was out.
Yeah, these are all fine. These are all fine. Now, continuing so. Proper partial fractions. So what we're looking at... Okay. Proper partial fractions. She just decided no. That's fine. No, nobody's compelled to be here. You know, it's entirely up to you.
She's already marked absent.
Well, I suppose you could stay and learn something. Yeah. Right. Proper partial fractions. So, just to get started, just to get just warmed up, I want everyone just to add these two fractions together. Just add these two together to make it one fraction, okay? Yeah. Yeah. Okay. Anyone got an answer yet? Yeah, so on the top it's that times that plus that times that over x squared plus 3x plus 2. So you're left with 2x plus 3 over x squared plus 3x plus 2. Okay. So what we want to look at today is it possible to do the reverse? That is, to start here and work back to these. Now that's actually pretty difficult to do. Obviously it's easy to go from here to here, as you all did it. It's quite difficult to go backwards. There's a couple of techniques for doing that. And really this is best demonstrated with some examples. Can I scroll down? Yeah. So, let's say I have minus 12 over 3x squared plus 8x plus 4. Okay, well, if we try and think about this backwards, it might be useful to factorize the denominator, which would be 3x, x, 2 and 2. Or 4 and 1? 2 and 2? 2 and 2. Now if you think about the previous step, what must have been the previous step to get to here? It must have been that you had something over 3x plus 2 plus something over x plus 2. So we've turned the problem into trying to figure out what must have been this number and this number, so that when I add them together, I'll get to this guy up the top. Yeah, you can see that's the kind of the idea here. Okay, so let me just carry this down here. Minus 12 over 3x squared plus 8x plus 4. What I'll do, there's a couple of ways to do this. I'll show you the few methods. The first thing you could do is multiply both sides by 3x plus 2 and x plus 2. 3x plus 2, x plus 2. And then likewise here, 3x plus 2, x plus 2. Okay? Now, on the left, what happens here? Yeah, this cancels all of that. Here, this will cancel that one, and here, this will cancel this one. So now you're left with minus 12 equals a x plus 2 plus b 3x plus 2. Now, the way to do this, I said there's two ways. The start is the same for both ways. It's only at this point can we choose two different paths. So what I'll do is I'll break this page in half and I'll show you method 1 and method 2. Like that. Okay. So the first method is you expand on the right. So you get minus 12 equals ax plus 2a plus 3bx plus 2b. Is that okay? So on the left I get minus 12 equals a plus 3bx plus 2a plus 2b on the left. Is that right? A plus 3bx, 2a plus 2b there. Okay, and just to make it even a little bit clearer, on the left I'll write 0x plus minus 12 equals a plus 3bx plus 2a plus 2b. That's it, yeah. So I'm trying to make a comparison. Can you see on the left I have a linear equation. On the right I have a linear equation. If they're supposed to be the same, then it must be the case that the constant a plus the constant 3b has to equal 0. Yeah. And then the constant 2a plus 2b has to equal minus 12. Or perhaps, yeah, a plus b equals minus 6 if you divide by 2, which is a little bit neater. And this isn't so difficult to solve. I can just minus them. So I get 2b, 6, and so b is 3, which makes a equal to minus 9.
Wait, I think we need some money.
Did I? I don't think so. I think it's okay. So that means back at the original here, that's equal to, it was equal to a.
Minus 9.
Yeah, minus 9, isn't it? Yeah, plus b, which is 3 over x plus 2. So I've successfully broken it back down into what's called its partial fractions. Right, so before I continue, I'll give you a minute to write this down. We'll have a look at the second method. Yeah?
Can we skip the step of multiplying by 3?
Yeah, that's fine. And just go straight to the, yeah.
Just multiply by
Yeah, that's fine. That's fine. Yeah? Who the heck is that? They threw something at the door? Bunch of weirdos. Alright. I just had to put it in to match the left and the right. Okay, you got that? Yeah. Have you got that written down?
Sir, if you can't factorize, can you just multiply by the quadratic?
Oh ho, if you can't factorize, that's a problem. Later. Yeah, that's the next thing. Okay, continue. So the second method, you have, guys, minus 12 equals ax plus 2 plus b 3x plus 2. And what you have to realize is this isn't really an equation, because you can never solve this for x. To be more precise, it's what's called an identity, which is represented by 3 lines. Now, I'll explain what an identity is on the side here. So if I said to you x plus x equals 0, what's x? 0. Because you get 2x equals 0, so x equals 0. If I said to you x plus x equals 2x, that's true. I think we can all agree on that. What's x? Don't know. Although this isn't false. So to be more precise, we call this in maths an identity, which means you cannot solve for x, but it's still a true statement. And it's true for all values. For all values of x, it's true. So for example, if I sub in 1, I obviously get something which is true. Don't I, Aria? 1 plus 1 is 2? Yeah, okay. And then if I sub in 2, I get something which is obviously true as well. And so on. I haven't forgotten. These are called identities, okay? So if I go back here, this really is not an equal, but rather an equivalent, an identity. This means this is true for all x. Well, if it's true for all x, it's going to be true if I choose x equals minus 2. What happens if I choose x equals minus 2? I'll get minus 12 here. What will this become? 0. Minus 6 plus 2 is minus 4b. So b will equal minus 12 over minus 4? 3. The same. If it's true for all x, it's also true if x equals minus 2 over 3. Minus 12 will equal a times 2 minus 2 over 3, 4 over 3, plus 0. So that's going to be minus 36 over 4. What's minus 36 over 4? 9. Minus 9. Which is the same. So this method is quicker. However, it has a disadvantage, which I don't particularly like. It's a very significant problem. Can anyone see what is the problem with this method? What's wrong with the values? Huh? Well, the sentences are kind of breaking off here. Can anyone give me an answer and finish their sentence?
It's not valid for the linear equation.
It's what?
Not valid.
That's it, yeah. It's not valid in the original equation. So if you look back at this guy, this is true, except you're not allowed to make x equal to minus 2, and x can't equal minus 3 over 2. Why not? You should divide by 0. So you normally can't do that in maths, except for this one example here, which is why I don't like it, because it's an exceptional method. It only works for these problems, which is why I'm not so keen on it. But it's fine for these types of problems to sub in these forbidden values to get the a's and the b's here. Yeah?
Do we need to know both methods? Or can we just know one? Because the first one makes sense.
You can, yeah, to answer your question, the exam will not specify a method. Yeah. Can I just borrow your calculator there for a sec? So write the second method down, please. Yep.
Is it always wise to pick the
The forbidden values. Yeah. It makes it much quicker. Otherwise, you'll return to the problem you had, or not the problem, but you basically return to method 1. Yeah. Okay. Now there is a third method which is the shortest of all the methods. However, the disadvantage with the third method is it only works for the simple problems, which is like our first example. It doesn't work for the more difficult problems, but it's a good method for questions like this which would occur in section A. This would be a section A question. It's not so long. Okay, so if I can scroll down, or well, can I look at method 3? Yeah. So method 3 is the easiest method and the quickest method, but like I said, it only works for the simple problems like this. What you do, if I zoom back in, you take your fraction and you write it as, you factorize it as normal. Then what you do, and then you write it like this. So let me just delete this here. Okay, so we want to get this number and we want to get this number. What we do is we go to this equation and now this method is just like a rough work method. You delete this, but before you delete it, you just ask yourself, what value of x can I not use here?
Minus 2 over 3.
Minus 2 over 3, okay. So you delete this, and you sub in minus 2 over 3 here. See what you get. So minus 12 over minus 2 over 3 plus 2. Minus 9, which was A.
How do you know it was?
Because I deleted the 3x plus 2, which matches up with that one. Now I want to get this one next, the x plus 2 one. So what I do is, what value of x can I not use here?
Minus 2.
I delete that and put in minus 2 here. So minus 12 over 3 times minus 2 plus 2. I should get, no, 3 I think. I got 3? So I got minus 9 and 3.
That's 3.
Did I get, it's the wrong way around? What was A?
9.
A was
9.
minus 9, yeah. So minus 9 and 3.
Yeah, but we got 3 for the 3x.
This one is 3?
I got 2.
Hang on, what are you saying?
We got 3 for A.
Yeah.
Oh, I thought someone said it was minus 9.
No, A is
When
minus 9.
you deleted x plus 2 and you said to sub in the x cannot equal to minus 2.
Into the, yes, yeah. What did you get?
You get 3.
You get 3.
Yeah.
Which is the A or the B?
Which is the b.
Yeah, which is in the right position here, isn't it?
Yeah. Yeah.
Don't be confusing me, man.
Yeah, A is minus 9. It's correct.
This is right.
Yeah.
Yeah, okay. Okay. So just to recap, this method is very convenient. So just, again, to go through the process, you want the 3x plus 2's number. So you say, what can I not use? I can't use minus 2 over 3. You delete that and put it into the x here. Gives you the A. You want to get the b's number. So what value can you not use for x plus 2? Minus 2. You sub that in here. Okay. So it's a great method for a short question like this.
Can you use it in the exam?
You can. Yeah. Yeah. So this is an example of a method whereby if you get the right answer, you get the full marks without any work. However, the risk you play is if you make a mistake here, then you get 0 marks because you're betting on getting it right and getting the full marks or nothing. So, you know, these are the things to consider about which method you choose to do. Right, let's look at another example. Can I scroll down? Yeah. So look, I'll give you one to try before I do a harder one. And you can use any method, method 1, 2 or 3, whichever you prefer. So we'll just take the second one here, which is minus 22x plus 62 over 45x squared minus 19x minus 42. Yeah, well, you'll have to first figure out what the denominators are. Okay, if you were using method 3, you should be finished by now. You're not using method 3, huh? This is literally the last one you just saw.
Okay, I forgot what to put in the numerator.
Yeah, that part's a little tricky. Yeah.
Is the numerator 0?
One of the numerators could be 0. That's not a problem, I don't think. It's a bit unusual, though.
I didn't use it.
Mosa, please, don't use your phone. I want you doing these. Thank you.
Use the first method. What does it equal?
Well, I'm going to do it now, but I'm going to use method 3.
Can you read this?
Okay.
Please.
Which method did you use? It took you this long?
Yes.
Which method were you trying first?
I tried the first one first.
And
Then I erased everything. It was very long.
are you finished over there? You got finished? Mo?
I'm doing method 1.
Okay.
Because you always get an answer.
What are the two factors here?
5x minus 6
6 and then
and 9x plus 7.
like this. And we have to figure out this number and this number.
Can you do it?
Hmm?
Can you do it another day? The first method.
Yeah, please.
Okay. A, B. So I'll multiply everything by the two factors. 5x plus 6, 9x plus 7. 5x minus 6, was it? Or plus 6?
Minus.
5x minus 6, 9x plus 7. 5x minus 6, 9x plus 7. And what will happen is both these guys will cancel with that. The first one cancels with the first one, and the second one will cancel here. So you're left with minus 22x plus 62 equals A, 9x plus 7, plus B, 5x minus 6. When you expand this and group together, you'll get 9a plus 5b x plus 7a minus 6b. And here you have minus 22x plus 62. Therefore, it must be the case that 9a plus 5b is equal to minus 22, and 7a minus 6b is equal to 62. Now, what I'll do is I'll add these together. So I'll get no, I can't add because I want to cancel something. So it means I'll have to do some kind of multiplication. I'll have to multiply by 6 and 5.
Why don't you just use substitution?
No, I think this would be this, although messy, the A and the B. Okay, well, I'll just go through the process. So, can you help us out here? If I multiply by 6, what will I get? 54A plus
30
B.
minus 132.
And then this is 35A minus 30B is, what's that? 310. Right, now let's add them together. 89?
Yeah.
A equals minus something.
178.
178. So A equals plus, thank you. So A equals 2. If you sub that back into anybody, you'll get B is it minus 8?
Yeah.
Right, so we have our A and our B now. But you could have used the method, the method 3, which is you first change this into 5x plus 6, 9x plus 7, minus 22x plus 62. And to get the A, you cover up this and sub in the forbidden value, which is minus 7 over 9. So minus 22 times 7 over 9 plus 62 over 5 times 7 over 9 plus 6. Oh, thank you. Minus and minus. So that will equal 2. And B will equal... hang on, do I have this backwards? Was that B? That is A?
Yeah.
And to get B,
Remove the 5x plus 6.
Oh my god.
I cover it up. Alright. I know I just taught you this 5 minutes ago, and now I'm starting to doubt myself. Okay, so the B, I have to cover up 5x plus 6 and sub its value into the other one. So that will be minus 6 over 5 plus 62.
No, it's plus 6. If the factor is minus.
5x minus 6.
Oh, it's minus here. Sorry. That's minus, thank you. So in this, I should have wrote minus here. Yeah, thank you, okay. So this is 6 over 5? Okay, over 9 times 6 over 5 plus 7. Okay, and that works out to be minus 8. Alright. Yeah, well, we're going to have a look at more examples now. Okay.
Sir,
What? What's that?
and that's 2.
For what?
When I plugged in B.
So, my doubt was right.
I don't know.
Guys, I know, I appreciate you telling me I was right. Like, that is nice of you, but I had a feeling I was doing this backwards. If you type this in on the calculator, do you actually get -8 or do you get 2? Why don't you type it in and see?
You get 2.
I just gave up on it.
Guys are messing with my head. So I was, yeah. So I was, as I was saying, I thought this was the other way around, B and A. Now the way I remember it is like this. Listen, because everybody got this backwards, because you were all telling me I had it backwards. The way I think about it is, here the B is over the 9x plus 7, right? So if the B is the one that you want, that's the one that you delete from the question. So here the A is the one that you want, and the A goes with the 5x plus 6. So that's the one that needs to be removed from the question. Okay? So, yes. These are backwards. Let me just fix the numbers here. Now I'll say it again and just listen carefully. Okay? In this one here, which did I remove? I removed this 9x plus 7. That corresponds with the B. That means this is the value for B. Okay? Which worked out to be, what's that? -8. Now, this one here, what did I remove to get this one? The 5x minus 6. That corresponds with the A. So this was the value for A, which is 2 then. Okay.
What if you factorize on like the other way? You can easily factorize the quadratic to 9x plus 7.
Yeah, that's fine. So if these guys were swapped, then in your answers they'll be swapped.
That's wrong.
No, it works out to be the same.
Because you're always going to put A and B.
And the A is just letters we're giving them as placeholder names. They don't have any meaning. I could have called them P and Q. It doesn't matter. Okay, continue now. So far you've seen that the only ones we've done have quadratics in the denominators. Yet now we'll have to look at cubics. But what about if the quadratic doesn't have factors? Well, that's a problem, but that's not a problem that we could get here because we have to have some kind of factors, otherwise we can't break it up. But what we could have is a situation like this. Can I scroll down? Yeah. So try and factorize this and see what it could possibly be. X squared minus 10x plus 25. What is it? No, that's a plus 25. What are the factors?
X minus 5 squared.
It's x minus 5 squared.
Yes.
Now this gives us a bit of a problem because you might think, well, okay, so it's x minus 5, x minus 5. So that put x minus 5 here and x minus 5 here. A and B.
If you try method 3, you're going to get 200.
Yeah, well, there's a problem here with this. You might then say, well, hang on, these both have the same denominators. So why don't I just put them together as x minus 5, and on the top here you have a plus b. Well, if a is a constant and b is a constant, then a plus b
Must be
is constant. There is no value of c that I could ever find that would make this fraction turn into this. There's no number I could put here that would make this fraction somehow become this. Impossible. So, what we've done so far doesn't quite work for these situations. There must be something else to it. So this is what happens when you have what's called a repeated factor. You write the first one, x minus 5, And then the second one is not x minus 5, but you write it as x minus 5 squared. Now, if you were to multiply these together, it will produce a fraction whose denominator is x minus 5 squared.
Oh.
You can add these together to make this denominator. Can you see or not see?
Yes.
Some can see, some can't see. Can you see?
Yes.
No? So, watch. If I was to multiply above and below here by x minus 5, then these are the same. And then this guy here would be x minus 5 squared, which it should be, right? What type of equation is this? Linear. Plus a constant is also going to be linear, which is exactly what we have, a linear over a quadratic. So before continuing, I just want to go to the side and give you the guidelines here. So usually for these problems, you start off with something which has, it could be a linear, it could be a quadratic, whatever, and the denominator should be something higher. So this should be more, higher degree than the top. So what I mean by that is we're only looking at problems like linear over quadratic, or maybe linear over cubic, or quadratic over cubic. Not cubic over quadratic, or not quadratic over quadratic. It has to be that the bottom is higher than the top. Okay? Now, what really happens next depends on how you can factorize this. So let's say this has power n. For example, if n is 3, we say it's cubic. If n is 2, it's quadratic, and so on. What we really, really would like, we'll say n, is if there were n factors. That would be perfect. So you would have just factor 1, a constant, factor 2, a constant, and so on. Okay. That's not what's happened here. How many factors do we have here? I should say, how many unique factors do we have? 1. And how many do we need? We need 2. So this is where we get the problem. Factor 2, dot, 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 dot. Now, if they repeat, what you can do is then take the factor that's repeated. So let's say it's this factor, and then just add in another factor squared. So, in other words, if you're missing a factor, then you can add an extra one in by squaring the one that's repeated. So, here I should have 3 factors. If I only have 2, I can add the extra one by squaring the one that's repeated. So here, if I go back to this, I should have 2 factors, I only have 1. To make the extra factor, I square the repeated one. Is that okay? Yeah? No? What's confused you?
The last word.
The part that I said 5 times?
Yeah.
Okay. Tell me the moment my sentence starts to not make sense. So, here this is quadratic. What power is quadratic? 2. How many unique factors should we have? 2. How many do we have for this one? 1. But we need 2. So we make the extra one by squaring the repeated one. Okay.
So,
Yeah.
if it was a cubic,
Yeah.
and we got 3, is that still possible?
I wonder if I put that one in for you. I don't think I was that much of a jerk, Angela. Yeah, but to answer your question, if it was cubic and it was repeated just 1, then yeah, you would have the factor squared, and the factor cubed. You can make the extra factors by just increasing the power. Yeah, but I did not give you that. Yeah, and I don't think they would do that in the exam. That's pushing it too far, perhaps.
Doesn't one factor another factor squared?
No, you can reduce this to a quadratic. It doesn't actually become a cubic. It doesn't. As I showed you earlier, remember when I multiplied above and below here by x minus 5?
Cancels out.
Yeah, it does reduce to a quadratic, not a cubic. So it's not a problem. We haven't broken the power here. Okay? Right, continue. Now, here's the next thing. On the numerator, we wrote a constant. But it's not always going to be a constant. Sometimes it could be something like a linear or a quadratic even. How do we know what goes in the numerator? Most of the time it is a constant, but there is a rule for figuring it out. So the way I think about it is like this. On the bottom here, it could be something like a linear or quadratic, whatever. Let's just say it was something like a linear, like 2x plus 3. I know the top must be a constant, and the reason I know this is because how many coefficients do we have here? We have 2. I know whatever goes on the top must be one less. So instead of being a linear on the top, it would be a constant. Now, suppose I had on the bottom something like 2x squared plus 3x plus 1. How many coefficients here? 3. So on the top, I should have 2 coefficients. Yeah. Yeah. Or 1, because one of them could be 0. But I'll write down 2, and maybe one of them works out to be 0. That's fine. Okay? Yeah. And also, the last rule is the top should be one order less than the bottom. So if this is quadratic, then the top should be linear. So likewise here, if I go back to my question, if this is linear, then on the top should be, what's below a linear? A constant. Now this is where it gets a little bit different. If this is quadratic, what should be on the top? Linear. How many coefficients here?
3.
No, 2. 1 and minus 5. I know, but no, just not expanded, just the original here.
I think this is one of the things that makes more sense if you solve.
Yeah, well, I'm going to do it. I just want to explain the rules. So, how many coefficients here? 2. 1 and minus 5. So how many should I have on the top? 1. So think carefully. It needs to be one coefficient and it needs to be linear. So you actually have a choice. You can either use b, but what's another possibility? Bx. Is that linear? Yes. Does it have one coefficient? Yes. Which do you choose? Doesn't matter. You'll get the same answer either way. Okay? So you might want to write these rules down. I'll just recap them. I think of them as 3 rules. Okay? First rule, now before you write it down, just listen, process it, and then put it in your words. Okay? The first rule is the number of factors here should equal the power here. If you're missing a factor because it's repeated, you can make the extra factor by squaring the one that's repeated. Okay? Alright, so I'll give you a minute to try and put this in whatever words will help you remember it, and then we'll look at the next one. And don't shake your head. You asked me to individually explain that rule. Okay. Oh, that's a shake of, this is good stuff. Like, That is some good maths. Yes. No, not quite that. No, use your words. What? You're making me write a sentence, right?
The number of factors should equal the power if repeated square the extra factor.
Wow, that's a bit confusing to me. Right, okay, Angela. The number of partial fractions, that's these guys here on the right, should equal the degree of the denominator. If you are missing a factor, because it's repeated, then square it to produce one more term. Now, how is that in any way better than what you could have written? Seriously. My English is terrible. I'm just like, I know it looks like I'm speaking English, but I'm more just like a trained parrot. Like, there's no meaning behind this. Right. I would feel better if you wrote it in your own words. Okay. Next rule. Can I scroll up? So the next rule is that, guys, in the partial fraction, the numerator should be one order less than the denominator. E.g., a constant goes over a linear. A quadratic goes over a cubic. It's exactly one order less. In the numerator of the partial fraction, it's one order less than the denominator. Or you could say 1 degree less, whatever you prefer. Maybe 1 degree less might be better. And you could even write examples, e.g. linear over quadratic, quadratic over cubic, or this. Yeah? You got that rule? Yeah? Third rule. The number of coefficients in the numerator is one less than in the denominator. The number of coefficients or constants in the numerator is one less than in the denominator. No. No. I know it seems very much like it. It's actually different. And I can give you an example to be clear. The number of constants in the numerator should be one less than the denominator. Do you know what? I'll just start this one again with our 3 rules so it's a bit neater. Okay, do you have that? Right. Now, I want everybody's full attention because, as I promised, these last few lessons get quite difficult. And we're only in the first one of 4. And I think you already agree it's getting pretty difficult. Okay? So just listen, please, carefully to the process here. First, you look at the denominator. This denominator is power 2. According to the first rule, I should have 2 partial fractions. So I'll make a space and do space plus space. That's according to the first rule. Are we happy with that? Rule 1. Okay. Now, let's figure out the denominators. So we factorize this, and we get one of the factors is x minus 5. However, we discover that both the factors are actually x minus 5. So the problem now is we have to use rule 2. We're missing another factor here. We can produce an extra factor by squaring this guy. Now I've made a second factor here. That's rule 2. Okay, now on to rule 3. This is linear. No, I was still using rule 1, sorry. Now on to rule 2. This is linear. So this guy here must be a constant. Right, well, we don't really have any choice about it, that just means it's A. Now this is where you need to be careful. Rule 2 and rule 3 together here. This is quadratic. So on the top here, this must be linear. However, now please watch carefully. If I write a linear here, I have now broken rule 3. What does rule 3 say? The number of constants on the top should be 1 less than the number of constants on the bottom. How many constants do I have here? I have 2. I've broken rule 3. I can fix rule 3 by deleting one of these. Yeah. delete in C. But by the way, if you chose to delete B, it would still work out okay. But I will choose to delete C, because if I delete C, I can keep all three rules true. Okay, rule 1. Do I have two factors? Yes. Yes. And I've made the extra factor by squaring the first one. Okay. Rule 2. Is the top one order less than the bottom? Quadratic linear, or sorry, linear constant, quadratic linear. Is the number of constants in the top one less than the bottom? 2, 1, 2, 1. Okay, so I've now figured out what form the answer should be in. It should be in this form. Okay, so let's go through this one together. We'll have to use method 1 or method 2 here. I'm not 100% sure if method 3 now works because the problem has become a little bit more complicated. So we'll use method 1 or method 2. Right, so what should I multiply everything by? X minus 5 squared. So that cancels that. If I write x minus 5 squared here, that cancels that. And if I write x minus 5 squared here, that cancels that. So now you're left with minus 6x plus 22 equals a times x minus 5 plus bx. Yep. Okay. What should I choose for my x first if this, I'll go method 2. If this is an identity, what would be a good choice for x?
Plus
5 or
0.
0. 0 is quite good. Let's start with 0. So I get 22 equals minus 5a. So a is minus 22 over 5. Okay, what's a good choice now for another value for x? What is it? Say again, yeah, what?
I was saying minus 6, but that's
5. So if I choose 5 now, I'd get minus 30 plus 22? 8. This guy? 0. And this guy? 5b. Here I choose x equals 0, and here I choose x equals 5. Oh, sorry, that's not 8. Minus, is it minus 30 plus 22? Minus 8, isn't it?
Yeah.
Yeah. So b is equal to minus 8 over 5. So I got my a and my b here. So you realize what was kind of hard about this one is just getting it started. But then it's the same as what we did previously. Okay, write this one down. That is correct. Yeah.
When you multiply a by x minus 5,
We multiplied a by x minus 5 squared.
yeah,
Yeah.
and then multiply bx by x minus 5.
Squared.
No.
Yeah. We multiplied everything by x minus 5 squared.
Right? Because
We multiplied everything by x minus 5 squared. What's your question? I'm telling you what you did, now ask me your question. These three guys we multiplied by x minus 5 squared.
I do it with like crossing.
No. That's not how we did the other examples.
You can't do it with other. Right.
Okay. If you want to be like that, be like that. I'll do it that way now. By crossing. Yeah, okay, fine. But that's going to become method 1.
Yeah.
If you combine them by crossing, what you're doing is you're trying to make the left and right equal. So did you make it simultaneous? Yeah, so that's method 1, but I'm doing method 2. Do you get what I'm saying? We're doing it, you did it method 1, that's fine. I did it method 2, that's fine. Yes?
When you did x equals 0, you found a. What happened to the b?
What's...
Yeah, because
Yeah. Yeah.
I answered that question. But then when x equals 5, you subbed in a and x, right?
Yeah, but it wasn't necessary for me to actually sub in the a because it's multiplied by 0.
Yeah. Yeah.
But technically, yeah, the A got put in at the same
Yeah,
time.
but if it was like a
Yeah, if there
part,
was, yeah, and that does happen. Yeah. Okay. So we have to go on to cubic now. We've only done quadratic. Can you write? Have you got this written down? Yeah. Okay.
What is this exactly? It's not calculus, it's
No, it's going to lead into integration.
why do I not remember this whatsoever?
Guys, we still have 3 more examples to do because you have 3 cubic examples to do. So, in the exam, you don't get marks here for the factorizing at the first step. So you can use your calculator here to get the factors. Okay, even the Casio calculator can do this with mode 50 something for cubic, whatever. So what I want everybody to do for me on your calculator, take a look at G. I just want you to type in the cubic and give me the 3 factors, please, for G. Hold your horses. Hold your horses. Yeah. This is G. Go ahead. What's the first one?
4x plus 7.
Okay.
2x minus 5.
Okay.
7x minus 3.
Okay. So, according to the first rule, how many, if it's cubic, how many partial fractions should I have? 3. And do I have 3 here? Yes. Fortunately, I do. So this becomes quite straightforward. A, B, and C. Now, this is a really, really, really good example of why you should use method 3. Because this is already long to begin with. So, if I want this number here, the 4x plus 7, what value of x can't I use? Minus 7 over 4. So I need to delete this and then sub in x equals minus 7 over 4. So on your calculator, sub that in, minus 7 over 4. But do not type in the first factor here. This is method 3. Now I want to open up Derive here. Yeah. It's taking you a long time to type this in.
Yes. Five?
Correct. Oh, you are way off, Angela.
5.
5. What did you get? Not 5. 5. You all know how to type, don't you? I've seen you do it on your phone before, so I think you know how to type. Yeah.
Maybe we do.
Oh, sorry, you're not usually typing numbers on your phone.
You
That's
just have
the
to get
problem,
brackets
isn't it?
right,
Yeah,
so
okay.
You just have to add extra brackets.
Yes. What did we get here? If you typed it in correctly, you will get a 5. there's no need to go through the pain of doing the other two. I'll give you the answers. But just so we're clear, how would you get the second one? What value of x do you use? 5 over 2 after you delete this one. And how'd you get the last one? 3 over 7 after you delete that one. So I think it works out to be 5, 3 and minus 2, is it? Let me check here. 5, 2 and 2. Yeah. 5, 2 and 2. Okay, so that's an easy one to get started. Let's look at a harder one now. Can I scroll down?
They're really going to ask us this then integrate them.
Yeah, and they actually get harder because these are proper ones. These are the easier ones. Wait to see the improper ones. Exactly. Okay, so what I want everybody to do, please, for me now, is to have a look at h and again to factorize. Did I write that down right? No, I didn't. Sorry, what is it? 16? 16x squared plus 65x, is it? Over your cubic. 16, 65, and 18. Yeah, let me actually write it down. What is the cubic?
28x
Yeah.
cubed.
Yeah.
36x squared.
Yeah.
15x.
Yeah. Factorize the cubic, please. 7x plus 2. 2x plus 1.
X minus 20. X minus 20.
Huh? What? No. I think you're, yeah. No, well. Look. How many factors should we have? And how many do we have? 2. Therefore, one of them is repeated. That is, one of these guys requires a square. Think before you open your mouth. I know it's very tempting just to open your mouth without thinking. Resist the urge. Which of the two here must be the one with the square? You couldn't have thought that fast. Okay, fine. Which one? Which one has it?
2x plus 1.
Why did you choose that one and not the other one?
Because the first value.
Because if you square it, it becomes 4x, and square it and then times 7, that's 20.
Yes, you have to think about what the consequence of squaring is. The way I think about it is, if you square this one, then it finishes on a 1 squared. A 1 squared times a 2 is a 2. However, if you were to square this one, it would finish on a 4, and a 4 times 1 would finish on a 4 and not a 2. So it must be the case that it's this one here that's repeated. Which means, okay, so what 3 factors do I have here in my denominators? What's the first one?
7x.
Yeah.
2x plus 1.
2x plus 1.
And 2x plus 1 squared. Now, what goes on top here? A here, B, and here? CX would be best here. Okay? Right, alright.
What did you remove from the third one?
Huh?
What did you remove from the third one?
What did I remove from the third one?
Yeah.
What do you mean?
C.
It's CX.
Remove the C.
Yeah. By rule 3. I'm calling those 3 things rules. They're not really rules, they're just guidelines. But rule 3 sounds more dramatic than guideline 3. Okay,
You can't use method 1.
no, you can use method 1 and method 2.
I feel like,
What I'm not sure is, can you use method 3?
like method 1.
Yeah, that's what
Will we have a look at method 1?
Yes.
No,
I feel like
method 2. I don't like, the reason I'm not using method 1 is because I'll get it, well, yeah, why? Because I'll have a simultaneous equation of 3 ABC, ABC, ABC. I'm not sure if method 3 will work here, so we'll just use method 2. It's the safest method. Yeah. So what do I do first? I'll multiply everything by what?
7x plus 2, 2x plus 1 squared.
Squared. 7x plus 2 and the square guy and the square guy and the square guy. So what happens here? That whole thing cancels. Here, just the first one. Here, one with the power. And here, both them with power. So you're left with 16x squared plus 65x plus 18 equals a times 2x plus 1 squared plus b times 7x plus 2 and 2x plus 1. Finally, plus cx? Cx. Oh, times 7x plus 2. Right. So now we have to... that c looks a bit stupid there. Cx. I know it looks like a bracket. Okay. What would be a good choice for x first? So first we should choose x to equal, what would be good for the first one? I think minus 2 over 7 is good actually. If I choose minus 2 over 7, I could get what from this? I'd get a. Because what would happen here? 0. And here? 0. So I could figure out a. Okay. What should I choose next for x? A half. Minus a half. If I choose minus a half, what would that get me?
B.
B. Good. Okay. Now, lastly, what should I choose for x here? I still need to get the c, don't I?
Sub A and B.
Yeah.
Minus a half.
Yeah.
Minus how we got now?
Sub the answer for
No, just sub A and B.
Yeah, just sub A and
Yeah,
B.
you sub A and B and
Yeah, but I still need to put in something for x. So what I could do is I could just choose x as 1. I can't just leave x as x. I have to put in a value.
Yeah.
So I put in a simple value. And as you said, you also know a and b. So if you have a, b, and x, what can we finally get?
C.
Let's see.
So won't you get C in the second step?
Yeah.
Because
Oh, sorry, I have that the wrong way around, do I?
B-
Who told me b? If I choose minus a half, what would I get here?
C.
C, thank you. Okay. Right, so for the last one I need to get... Oh, right, well, this actually
Yeah.
is easier. What could I choose for x here?
Either.
Minus 2 over
No, what would be a very nice value to choose?
Minus 2 over 7.
Boom.
0.
0.
0. Because if I choose 0, this guy is gone. Yeah?
Oh, no.
This guy is just going to be 1 squared times a, which is just
one.
a, which I know. And so I can get the b here. Get the b. So by making the right choices of x, we can get our a, b, and c here. Okay? I don't think there's any need for me to sub those in and get them, is there? Because you're all experts at using your calculator. I think it's not necessary. Because there's still one more example I want to do before I let you try these. J. Yeah. Can I scroll down? (21x squared minus 35x plus 31 over minus 5x cubed minus 10x squared plus 10x minus 15. So I should have 3.
no factors. Yes, there is.
Well, there is at least one factor.
There's one factor.
Yeah, so 1 and no are two different things. You know, Like, if I said to you, how many medical degrees do you have? And you said none. Well, one. They're quite different, aren't they? Yeah, okay. So how many factors does it have? Okay.
1 cube.
Well, this is the thing. What factor did we get here? X plus 3. So what's happening here? What are the other factors? Well, they're definitely not linear, because if they were linear, your calculator would have found them. So what's happening? It's cubic, there should be 3. So what is the other thing here?
One squared and one.
Well, there's a few choices. There could be another guy squared. Or it could have actually been just the original x plus 3 cubed. Or there could have been an x plus 3 and a quadratic, where this quadratic has no factors. So how can we tell which one it is?
The last.
Magic aside, how could we tell which the last one is? Let me rephrase the question. Listen carefully. You have a cubic. You have one of the factors. How do you find the other factors? Divide. So, what was the factor? X plus 3. All right, off you go. No. Or I mentally blocked it out. Okay, do you have your quadratic? What did you get? Minus 5x squared plus 5x minus 5? Yeah. Right, so if we return here, what's the first one? X plus 3, wasn't it? And what's the other one? 5x minus 5x squared?
Yeah, it's 5x.
Minus 5. Now, how many should we have? We should have 3, and I only have 2 here. Now, if you want to make it a little bit clearer in the guideline number 1, you can count this as 2, because it's a quadratic. So it's like it has the weight of 2, just put into 1. Okay, yeah? Yeah. Is it plus 5?
No, it's minus 5.
Just sounds like you made a sign mistake at the end. Do you want to double check your long division? I'm pretty confident that it is minus 5 here, because I have the answer at the back. Alright, so this one obeys rule 1 if you consider the second guy has a weight of 2. So, what right goes up on the top here? A. Now, think about rule 2 and 3. What goes on the top here? Bx plus c. It's linear and it has 2 constants. and this here is a plus. What method would be best here? Again, method 2. If we jump to the interesting part, it's 21x squared minus 35x plus 31 equals a times minus 5x squared plus 5x minus 5. Yeah, plus bx plus c times x plus 3. Now this is a little bit more difficult, but let's think about what we should choose here. So I should start off by choosing x is what? Minus 3. And what will that get me? A. Good, okay. Next I should choose x equals what? 0. And what will that get me?
C.
C. Because if that guy's gone, you're left with C, and you already know A. So you can get C. Alright, and lastly, what should I choose to get my, I want to try and get my B? Well, it doesn't really matter. Yeah, just choose 1, because we already know A, and we'll know this, and we'll know this, and we know C, and we'll have here 1B. So we can get out the B by putting in X as 1 in the last one. So you can see now why I said these last 4 lessons will be double lessons. Because this is the easy one. Now I have good news for you for this question, which might make you happy. In the exam, not 100% of the time, but I would say 90% of the time, they actually give you this at the beginning. Now, not 100% of the time, 90% of the time, they'll give you this.
No.
What? This form?
That saves you long division.
Well, yeah. What I'm saying is, they may give you the form already, just cutting out the long division step. And also the factorizing of the cubic. Yeah. But it's not guaranteed. It's not like there's some rule that says you will always be given this. And in some cases, you haven't been. Okay. But I think this is good because I feel like once people can get to this step, it's not so bad. Yeah. Now, there's 10 minutes left, so it'd be really good to practice some of these. Okay. The way the questions work were A to J goes from easy to hard, and then K to T again goes from easy to hard. Is it? Sorry. Yeah. So in other words, guys, if you're wondering, the difficulty increases. So A and K are easy, B and L are harder, C and M are harder, and so on. And the hardest ones there, well, number 2. Number 2 is the hardest one there. Okay, I'll close this.
So this is all on video?
I sure hope I was recording. Yeah, I was. Oh, sorry, just before you start, just to prove to you that this works, can someone just read out what our answer was last time? What was the A? Yeah, the answer we just got. Come on, guys. Oh, sorry. Apologies. All right. Well, what's the last question we did where we did get A? This one here. No, this one here. The 522. Okay, so 5 over 4x plus 7 plus 2 over 2x minus 5 plus 7x minus 3. Like this, okay. So is that what we had? 142, 143, 37, 123. 1, 2, 3. So it checks out. It is the correct result here. Alright, now you can start them. I just wanted to prove that what you were doing for the last 2 hours wasn't nonsense.
Is it okay if I write a program that does this for me on my calculator?
If you can,
Yes, I can.
that's a strong claim.
You can, yeah. I'll
Yeah,
show
but
it to you next
no,
time.
no, I'm not doubting that it's possible. I'm doubting if it's possible for you to do it.
No, I'll do it, yeah.
Alright,
I'll
okay.
show it to you.
You can program?
Well, not. You just enter a formula and then it automatically does everything.
Okay.
You just